So letter B, again, we're going to solve for the reaction. The same from the same from A. Letter B here, we have a beam. And then what we're going to do is first assign letter to every change of loading from left to right. So from left, you have letter A. And then this distribution until here. So this point here is point B. And after that, there are no loads, but there is a support. So this would be your point C. And then from here, point C, until the last point or last end, or at the end, this would be your point D. Okay, and what we're gonna do now is draw the free body diagram of the beam. So we're gonna draw the beam again. So this is the procedure. So draw the free body diagram. Okay, after that, so let me draw first the beam, and here. So we have this one, the 10 kilonewton. So again, this vertical lines that I'm drawing now represents only represents only that this is part of a distribution. So the number of lines there has nothing to do with the intensity at all. So anyway, this is 10 kilonewtons per meter. And then let's get the resultant na lang sad. By the way, this is 4 meters. So the resultant, it's going to be at the middle. So it's going to be the product of the two. So it's 10 times 4, and that's equal to 40 kilonewtons. Okay. Next is we have let's copy the position of letters here. So this is A, and then this is B, and then this is C, and this is D. So at point D, there is an inclined force that's making 60 degrees from this horizontal. So this is 60 degrees. So we're gonna get the components also. So this is the component on the vertical side. It's 25 sine of 60. Since we're using this angle, so that component is opposite of the angle. And this one here is 25 cosine 60. Okay, and we're through with getting the resultant and components. Let's now write the support reactions. At point A, there is a hinge, so there would be force A vertical, and then force A horizontal. And then at point C, there is a roller, so we're gonna have a roller here. So this is C vertical. And by the way, these are distances 2 meters on the left and 2 meters on the right. Okay, so let's move this a little bit lower. This one. Okay, so we're now ready to solve for the reaction, starting with summation of forces horizontal, equal to 0 to the right positive, to the left negative. So the forces horizontal are AH to the right, and this one to the left. So minus 25 cosine of 60 equal to 0. And transposing that to the other side, it's gonna be 25 cosine 60. And then you have AH equal to, let's get our calculator. So that's 25 cosine of 60, and that's equal to 12.5 kilonewtons. And this is your reaction at A. Okay, next is summation of moment anywhere. So the position of the supports are at point A and C, so you get to choose either the 2 points. So I'd like to have the summation of moment at point A equal to 0, and later on I'm gonna use point C as the checking. Okay, so summation of moment at about point A. So let's try to get the forces CV, the force CV, and it's gonna rotate about point A. So this is the direction of CV upward, so it's gonna rotate counterclockwise, as you can see in the motion. So counterclockwise, so it's gonna be negative, and the moment arm is the distance of point C from point A, which is 6 meters. Next is this one. So the direction of this force is downward. As you can see, it's downward, so it's gonna make a clockwise direction about point A because the force is downward. So clockwise, meaning to say it's positive, so that's positive 25 sine of 60 times the distance is from this point D towards point A, and that's equal to 4 plus 2 plus 2, that's 8. Okay, the next one is this 40. So 40 is downward, so it's moving down, so it's gonna rotate about point A with a clockwise direction. So it's going to be plus 40 times the distance. What is that distance equal to? So actually it's 1/2 of 4. So this is 2 meters on the left, and also 2 meters from the right. So I'll just write here 2 meters as well. Okay, so the distance of the moment arm is 2 meters. And how about the horizontal forces? So horizontal forces of the beam will only pass through point A, so they're not included in the solution. So this is not included, even this one. So let's continue. We now equate this to 0. Transposing CV to the other side, it will become positive, so it's CV times 6 equal to 25 sine of 60 times 8 plus 40 times 2, and then CV is equal to, let's divide everything with 6, so that's 25 sine of 60 times 8, then plus 40 times 2 divided by 6. So our CV now is, you get your calculators, so that's 25 sine of 60 times 8 plus 40 times 2 divided by 6. So that's 42.2. So it's 42.2 kilonewtons, and this is your CV value. So this is the value of your reaction at C. So let's actually move it a little bit to the left, and let's have summation of forces vertical equal to 0. So upward positive and downward negative. So what are the forces on the vertical side? We have actually AV upward, and then also CV as upward forces, and then we have 40 as downward, and downward nga 25 sine 60, and that's equal to 0. Okay, so now we can substitute CV as 42.2 minus 40 minus 25 sine of 60 equal to 0. Transposing all the constants to the other side, leaving AV equal to 40 plus 25, they're gonna become positive, and then minus 42.2. And then we now have AV. So it's 40 plus 25 sine of 60, then minus 42.2. So the answer is 19.45 kilonewtons. And you have here the AV. So let's check whether our answer is correct or not. So let's do the checking. So by checking, by the way, I just like to move this or copy this one because it's quite far now with my screen. I cannot see anything anymore. So also let's make this a little bit cuter. Okay, so we have to check. Since ganina we had the summation of moment about point A and then we got to choose either point A or C, so the next option is doing the summation of moment about point C equal to 0, clockwise positive, counterclockwise negative. So this is the concept of checking. Let's start with AV. So AV is upward and it's gonna rotate clockwise. So it's upward, therefore it's gonna rotate about point C with a clockwise direction. So it's positive times the distance of point A from point C is 6 meters. Next is AV, 40, this one 40. It's actually downward, but it's gonna rotate about point C with this direction. So it's counterclockwise, so it's negative. So negative 40 times the distance from this 40 towards point C. So it's actually this distance. So pila na siya nga distance? It's actually 2 plus another 2. So that is the distance. So it's 2 plus 2, so that's 4. And then this one about point C, it's clockwise because the force is downward, so it's gonna rotate clockwise at point C. So it's 25 sine 60 times 2 meters equal to 0. So we're gonna investigate whether we got all answers correctly. Let's substitute AV. So AV is 19.45 times 6. So it's 45, so that is 45. And then minus 40 times 4, and then plus 25 sine of 60 times 2 equal to 0. So let's investigate whether we got it correctly. So that's 19.45 times 6 plus 40 times 4 minus 25. Oh, sorry, it's minus 40. So it's minus 40 times 4 and then plus 25 sine of 60 times 2. So we got our answer 0.00127, and that's equal to 0. So this is actually close to 0, so we can rewrite this as 0.00127 approximately 0, and that's equal to 0. Alright, so therefore this is correct. Okay, so this is our example number. This is our example.